Hello everyone, my name is Fernando Gasca and I am a software engineer with the Curry development team. In this short video, we will show how to perform dipole clustering. Firstly, we will use the automatic spike detection. After that, we will create a realistic boundary element model, and lastly, we will compute a dipole cluster. Let's jump to Curry, and I will now use this example data where we have interactive spikes coming from the left and right hemispheres. I will open the study, and I don't need to do any signal processing. I could just apply some filtering, a user-defined auto filter which applies a high pass and a low pass, and after that I could add a further step to my processing chain to apply the spike detection. I only need to choose to detect spikes and run the scan. After a few seconds, all spikes have been detected. We can even switch to review to start showing the spikes if we would like to go through them. But at this point, I would like to create a head model for the dipole clustering. So I will switch to image data and open the BAM-FEM geometry panel and just create a BAM head model using the built-in image data set from Curry. So I will press start and the segmentation will start, and this will effectively segment the different compartments in the head model and create a 3-compartment model with an inner skull, an outer skull, and a scalp compartment, which we will then use to compute our dipole cluster. Now the model has been created and I can switch to the All tab. At this point, I could display the cortex that has been created when I created the BAM model. I just double click in the 3D view scenario and I will just enable the cortex. I will now choose the head model that I just created by just opening the selection and choosing the BAM 689mm, which correspond to the 3 resolutions of the 3 compartments. After that, I want to make sure to have a single time point functional data cursor. I will open the events panel in the left hand side and just double click in the very first spike detection in the events list. This will bring me to that time point and also make the functional data cursor a single time point because I want to have only one dipole per spike sitting at the top of the spike. I can also switch the maps to topography maps and choose to compute a moving dipole and start the dipole cluster. Just press the dipole cluster and this will start going through all the spikes that I have in the events list and create one dipole for every single spike. We can see that the clusters are forming on both hemispheres, and now we could switch to the functional data in 3D views, and I could change the view to a top view so that we can see both clusters. And what I can do now is show you how to find possible outliers. So for example, this one dipole is in the middle, so it looks as if it could be an outlier. If I press the shift key in my keyboard and double click on the dipole in the 3D view scenario, this will take me to the corresponding event which creates this dipole. Let me switch back to the event and I can delete this event if I would like to, so that it is not considered if I would like to create a dipole cluster again. Observing the clusters in the 3D view scenario, we get a sense of the spatial extent of the epileptic discharges in both hemispheres. Please note that while on this example we use the automatic spike detection to generate the spike events, these events could come from either manual marking or from template matching, for example. So it doesn't matter where they come from. The only important thing is that you have the marked events in the event list, and once having this, you can compute the dipole cluster. With this, I conclude this video and I thank you for your attention.